everyone, welcome to lesson 27.2, part 1. Today we are going to talk about our final conic section, the hyperbola. And the hyperbola lesson starts on page 365 in your Springboard book. So we see on page 365 the definition of our hyperbola, and I like to think of them almost as like a double ellipse, really, because we're taking that vertical cut into our double napped cone, and the kind of these double outwardly facing parabolas are officially our hyperbola. Now, the rest of the lesson kind of goes through the derivation of where the formula comes from. But if we look on page 368 at the bottom, so if we skip through a little bit of this, we see these formal definitions of our hyperbola. So this is at the bottom of page 368. And notice the equation, while it kind of looks like a parabola, it officially has a very, very similar equation to our ellipses, actually. Now, notice the big difference with these, though, are that it is subtraction inside here as to where our ellipse is always a plus sign. And then the other big thing is A is no longer the biggest parameter. It's now C that's the biggest parabola. And that, or parameter, excuse me. And that goes back to, if we look back at these hyperbolas, the C value, the foci are going to be farther away from each other than the vertices are of our hyperbola. So that's why A is going to be smaller than C, which is a change up from what we were used to before with the ellipses. So that's the big thing here, is that now C squared is equal to A squared plus B squared, not A squared equals B squared plus C squared. Okay. The other big difference is, notice the parameter that comes first, either X or Y, is going to dictate if it's a horizontal, so opening side to side, versus a vertical transverse axis. It's kind of like the major axis, opening up and down. So notice if Y comes first, it's vertical, because again, A squared and B squared this time are actually going to stay put in the equation. And then the center, H and K, H still is always going to go with X's, and then K is still always going to go with Y's, okay? The other thing you're going to notice is that there are asymptotes involved, aka lines involved, with our hyperbolas. So for our horizontal hyperbolas, we see that they open, it opens side to side, and the equation of the two lines is either positive B over A, because you're rising B, running A, think slope here, or negative for our decreasing line, you're going down B to the right A for that. It flip-flops, if you'll notice in your book, and be careful, there was a typo in your book, this is on page 369, for the transverse axis here. This time it flip-flops, you're rising A, running B to kind of get those horizontal, those asymptotes that help us draw in our hyperbola. Okay, so today's big focus is going to be actually sketching the graph, and that's what we're primarily going to focus on with this lesson. Okay, so as we look here, notice we do not have our equation in that standard form. So you probably are thinking, well, we're going to have to complete the square. And the process is going to be really similar to how we complete the square for an ellipse. So you want to write kind of tiny, or maybe on a separate sheet of paper, because they put number 6A on page 369 in kind of a weird spot. And what we're going to notice, and just like we've been with completing the square for all of our conic sections, you're going to want to group this so that we have our x's together. And then notice the y value this time is negative, so we're for sure going to put that second here. And then just like we've been doing, the non-variable term gets kicked to the other side. And similar to with an ellipse, if there is a greatest common factor to take out, make sure you do so, okay, to be able to complete the square, and be cautious as you're adding to the other side. Now, in the case of our hyperbolas, officially we will have a -1 to take out here. So be careful, we're going to take out a -1 as a greatest common factor here, which means that it's going to be positive y squared. And then be careful, because we're taking out this -1, it's also coming out of the -4 square. So now we have, -4y, we're now going to have positive 4y. And then again, we have the 4 that we'll have to add our 2 blanks to on this right-hand side. So divide by 2 and square. We are going to have 4 here. But remember, when we add to the other side, it's 4 times 4, so 16. And then same thing here, divide by 2 and square, we're adding 4 to the right-hand side here. But when we add to the other side, it's negative 1 times 4. So actually notice we're going to be subtracting 4. So this is like the one and only time you'll see the subtraction come into play. So on the right-hand side, we're going to factor. We have x minus 2 t squared minus y plus 2 quantity squared. And then on the right-hand side, 4 plus 16 minus 4 is 16. And last but not least, divide everything by that 16. So we get this equal to 1. And we end up with x minus 2 quantity squared over 4 when we simplify the 4 and the 16. And then y plus 2 quantity squared 16. That didn't simplify at all. So what we notice here is this is going to be horizontal opening because the x squared is first. And then a reminder, a squared is always going to come underneath the whatever term is listed first. B squared is going to be underneath whatever one is listed second. So we're going to have a is 2, b is 4 when we square root those. And then c squared is a squared plus b squared. So c squared is 20. And so the square root of 20, remember if we square root 4 times 5, 4 is a perfect square. The 5 is left over. So 2 square root 5, which I'm going to approximate is about 4.5 for graphing purposes. Okay, 2 square root 5, or square root of 20. Okay, so our center is going to be at h comma k. And that's still going back to how it's been found previously. So the center is at positive 2, negative 2. So we're going to plot that center point. And then since this is a right and leftward facing parabola, our transverse axis here, which is kind of like, it's not really the major axis, but the transverse is always going to be associated with your A parameter. So we're going to go to the right and the left 2 units since that's parameter A. And then parameter B is going to be what we call the conjugate axis. And that's going to be 4 units above and below. So 2 and negative 6. So now this is where kind of the fun part begins. So you have this almost like little box being created right now. And with the A parameters and B parameters, we're going to put kind of this box in here. And where the diagonals of the box are kind of hitting, we're going to sketch in our asymptotes. Oops. We're going to sketch in these asymptotes. And again, we're going to start at these vertices, and we're going to go along here to the right and the left. And then our foci are going to be inside there about, this is where the 4.5 came into play. Our foci are inside there. We're going to go about 4.5 units from the center each way. So that would be here and here. Okay, because again, kind of like the parabola, the foci are inside. Okay, so if we're asking for a specific location of each of these points, then again, our vertices, oops, here, I'll write it over here by the center. The vertices, again, were to the right and left 2 units each. So at 0, negative 2, and at 4, negative 2. And then we had the foci on these. We don't really talk about the covertices with these, which were, again, even more to the right and the left. They were at 2 plus 2 square root 5, comma negative 2. And then when we move to the left, 2 minus 2 square root 5, negative 2. All right, our next one then, one more example with these completing the squares. Okay, this time you want to be careful because notice that we have a negative on the x squared. So this time we're actually going to write this. I know this is very different than what we've done before, but we're going to order this so that the y's are actually going to come first and the x's second, because we want that negative x squared variable, whatever it may be, to kind of go by itself. And then the 32, remember, is going to get moved to the other side because we only want the variables on the left that we can find the square of. Okay, so the y's actually, we're going to notice we're not going to have to factor a GCF out. The x's, however, are going to have a -4 factored out. So we're going to be left with x squared, and then the 32 is also going to have a -4 taken out, so it's actually going to become -8x. And then our 32 will have two things added. So on the left, we're going to factor. We end up with -12 divided by 2 is -6. Squared is 36, and that's going to get added to the right. And then -8, -8 divided by 2 squared is 16. But when we're adding to the other side, it's actually going to be -4 times 16. So -64 on that one. Okay, would be added to the right-hand side. So as we factor, we have y minus 6 quantity squared minus 4. Don't forget that GCF out front. X minus 4 quantity squared. And then 32 plus 36 minus 64, though, is 4. Last but not least, we are going to want to divide everything by that 4 so that we finally get y minus 6 quantity squared over 4. These 4's cancel, and we're just going to be left with a 1 as our b parameter. So you can write that in if that helps, equals 1. So again, a squared is always coming under the first term, b squared is always under the second. So a is going to be 2, and b is going to be 1, square root of that. And then c squared is a squared plus b squared. So c is the square root of 5, okay? Which, to help us graph, is approximately 2.2. Center, be careful. Remember, the h still goes with x, the k still goes with 6. So our center is at 4, 6. So that's going to be right here, 4, 6. And this time, since the y is coming first, we are going to be opening up and down here. So our a parameter up and down would put our two vertices at 4, 8 and 4, 4. And then the endpoints of the conjugate axis, the smaller ones, the b parameter, b was 1. So we're only moving 1 unit to the right, 1 unit to the left. And again, we don't normally write those down. They don't have a special name, kind of like the covertices did prior to this. And then to actually get the graph sketched in, you're going to draw in this little box that kind of fits where our asymptotes will be. Our asymptotes will cut through those diagonals. And then we're going to draw in the hyperbola around it. Okay? Opening up and down again. Last but not least, the foci, again, are 2.2 away from the center. So in this case, very close to our vertices just inside there. So it would be just above 6, the square root of 5 from the center, and just below 6, the square root of 5, subtracted away. All right, now to finish things out on this particular lesson, if we look at the check your understanding, we'll focus more on this tomorrow as well when it comes to equation writing. But again, be careful with the hyperbola and the ellipse. Remember, hyperbolas are going to be using subtraction, while our ellipses are going to be using the addition between the x squared and the y squared. Both of them equal 1. And then the other thing to be careful of in hyperbolas, c squared is the biggest because it equals a squared plus b squared. And in ellipse, a squared is the biggest parameter. So it's going to equal c squared plus b squared. Okay. And again, we're going to focus more with this tomorrow, but just to get your brains kind of moving on this, when we talk about the center to a focus or to one vertex, again, we know parameters A and C by that information. Okay, so in this case, if we had to move to get to the other focus, if we started at 1 and moved to -3, that was 4 units. So our C parameter would be 4. And then if the vertex is at -2, we would have had to move, again, this is parameter A with the vertex, it's going to be to moving 3 units. So moving kind of the other direction from that center, if we're starting at 1, -3, and we had moved to the left 4 to get our other focus point, we're going to have to move to the right 4. So it would be at 5, -3. And our other vertex, again, would be moving to the right 3 units this time from the center. So that would be at 4, -3 would be the location of the other vertex. Okay, so those kind of ideas similar to the ellipses that are foci are with parameter C, and then the vertices are with A. Okay, even though A is no longer the biggest. Okay, now the actual equation then of our hyperbola is going to be dependent here. Now notice we moved left and right. So think about that means this is going to have to be a horizontal opening hyperbola if this is what was changing, if parameter or if the x value is what was changing. So the x is going to come first, being squared. Y is going to come second. That means node equals 1. And then parameter A squared is going to be 9. B we're going to have to figure out. The other thing we know is our h and our k are 1 and -3. So finally, last step, we need parameter b, which we know c squared, 4 squared equals a squared plus b squared. So 16 minus 9 is going to give us our b squared value of 7. Okay, so there would be the equation of our hyperbola. And again, we're going to work more with writing these equations of hyperbolas tomorrow. Okay, thanks everyone for watching, and we'll work more in class.